Thank you very much for introduction, and thank you everyone for being here. So I'll be presenting alone today. My name is AbdelRahman Elbadawy, and I'm from QSIT. I'm their International Sales Manager. And QSIT is an Esri Gold Partner and an Autodesk Gold Partner. We've been in the GIS business since 1994. We have more than 300 successful projects, more than 350 specialists, so on. Okay. So my agenda today will cover the following. I'll give an introduction about what we are doing for master planning and how we are helping in optimizing the educational facilities planning. Then I'll introduce the solution that we presented. And then I'll talk specifically about one client, which is TBC. TBC is a company which is owned by the Ministry of Education in Saudi Arabia, and it's in charge of managing the schools. So just to give some intro, all of the organizations have a supply-demand network that needs to be optimized. So you have entities, you have supply, and you need to distribute it on your demand. So you need to allocate which supply you're going to use to allocate it to the demand you have, according to some business goals and business rules. So let's take warehousing industry as an example, just to explain the concept to you. So in that case, our supply is the warehouse, and the demand are the stores. And our business goal could be minimizing transportation costs and having a maximum driving distance. That's our business rule, setting a maximum driving distance for our trucks. So here's our goal. And here's our rule. So we need to apply these goal and rule to get a set of rules to run our business. So usually the goals behind the optimization of supply and demand in public sector could be to provide high quality service to the community at a low cost. For example, where to allocate my bus stations, or where to have my fire stations, where to have my hospitals to be able to better serve my public. For the private sector, it could be warehouses and retailers, as the example I just explained, or how to optimize my delivery service and make it as efficient as possible and optimized in terms of cost and pricing. So we try to help maximize the value and the benefits and to minimize the costs and the drawbacks. So what we did is we're building a decision support system that can provide optimization recommendations based on a robust algorithm. So I'll just go into some business cases. For example, minimizing transportation costs. This is the one I explained for the retail and warehouses. This can be used, for example, in the Ministry of Supply for food security. For example, if you have your wheat inventory and you want to distribute wheat to bakeries. It can be used for post offices and the distribution of mail. It can be used for shipping companies from origin to destination. Another business case is maximizing the service area. So I have several depots or several facilities and I want to maximize the area that they serve. So how to do that? So for example, how to allocate my patients to my hospitals based on geography. So how can I utilize the number of facilities I have to maximize the number of patients and the area I'm serving? How can I optimize my school's distribution to serve more students? And this is the case we're going to drill into, the one we did with the Ministry of Education in Saudi Arabia. How to optimize my stations for transportation, for buses, for metro, and so on, and how to optimize the police stations to serve the citizens. Another business case is the delivery time. So how can I allocate as many customers as possible to a delivery site? How to deliver to allocate my ambulance units to the citizens, or my fire trucks to the citizens. Another case is how to minimize my facilities. Let's say I have lots of branches of my service and I want to minimize them, make some cost optimization. So how to do it? So now is the time to explain our solution. So what we did for, you have a supply and you have demand. So the demand could be to, how to, just let's give it 1 second. I have the call for prayer. I'll look at the chat meanwhile.
You seem to have lost your audio.
Yes, I'm sorry, there was just the call for prayer. So I just made a pause because it was interrupting my voice. Now, can you hear me back?
Okay. Okay, yeah, we can hear you.
Okay, so the overview is that we have a supply and we have a demand. So the demand could be deliveries, could be finding seats for students, could be the ambulance services, and the supply is the opposite, how you fill it. So what we did is that we built a model where you give your supply, you give your demand, and you pick up the filters. What are the business rules? What are we trying to optimize? And what are the goals and rules that we need to follow? Then we run the algorithm. Then we get a supply demand recommendations in map and tabular format. Just to give you how this works. So the input, I give my demands. So what are the demands I want to have? So for example, in the case of schools, my demands is that I want to reduce the overcapacity in schools, and I want to, if I have a school which only have 5 or 10 students, I want to distribute them among other schools to reduce the cost of that school. So I pick these demands and I give them order. Which one is the highest priority to achieve first? Then I select my supply. In that case, my supply would be the schools that still have capacity in them, or the schools which are under construction that will be ready soon. So I know how to distribute my demand on that supply. Then I start setting criteria. What are the criteria I want to do? In case of students, I would say, I don't want the student to be in a school that is more than 3 kilometers away from his home. I don't want a school to be having capacity beyond a certain threshold. Then I add some barriers in case I say I don't want the students to cross a highway or to go out of their neighborhood. Then I select the region I want to apply that filter on. Is it a city? Is it a neighborhood? Is it the entire country? Then we run the algorithm. Then we receive the output from the system. So we get a recommendation map. We get also in tabular format. We get a heat map with our demand to see how it's distributed. We get some statistics of how much money we're saving, how many schools we're opening, how many schools we're closing. And we can generate different reports. I'll dig more into the details of the case of the Ministry of Education in Saudi Arabia. So they had, what we did, we were supporting the educational planning of school facilities. So our goal was to have a nationwide school network optimization. You know, to have the right number of schools serving the amount of students without incurring extra costs or having students not allocated to the schools properly. So they had several challenges in the Ministry of Education in Saudi Arabia. They had some schools which were rented. So the ministry was paying monthly rent for each of these schools. So they wanted to reduce that cost by reallocating and reassigning the students in these schools to other schools which are owned by the ministry, or even to build new schools to accommodate them. They had also another challenge because they had afternoon schools. So some schools were running in the afternoon and in the morning. So you have a lot of operational costs to have the teachers and the alumni and everybody working at the same time. They also had some schools which had overcapacity. So you had more students than the number that should be allowed in the class. And they also had dilapidated schools which were in bad condition, and they needed to run a lot of maintenance on them. And they also had underutilized schools. You have a school in a rural area that has few number of students, and then you have, but still you need to run the school and have the full expenses to run it. And they also wanted to accommodate the future growth of students, because, for example, they were able to project the urban growth and the population growth. So they are able to expect in 5 years and 10 years how many students we'll have. So we need to have enough schools to accommodate these students based on the number of schools we have today. So just to give you an idea, in that case, we had a lot of different demands. So the demand was underutilized schools that don't have enough people attending them. We had afternoon schools that are running in the afternoon and are causing a lot of expenses for the ministry. We had rented schools that the ministry does not own, and they are renting them and paying monthly rent. We had dilapidated schools that are run down in bad condition, and we need to spend money on maintaining them. We had overcapacity schools with extra students than their capacity. And we had the future growth of students. And our supply, this is the demand that we need to solve. What is the supply that we are going to use to resolve this demand? So the supply was the undercapacity schools, the schools that still have room for additional students to join them. We had the empty buildings. There were some buildings that the ministry owns that could be used as schools. So that was supply that we could use to solve the problem. We also had the completed projects. The ministry was building some new schools. So once these schools are completed, they can come into action. So we can use them to resolve the issues of these ones on the left. And we had the ongoing projects, the ones that are being currently ongoing. They're still not completed, but they will be completed, let's say, next year or after 2 years. So they can be used to solve the students' growth, the future growth of the students. And we had the empty slots in the schools, because some schools just had a big plot of land and they had only one building built on top of them. So we had empty space on that land that we can still build another building inside the same school. And we had the white lands, which are just lands owned by the Ministry of Education, and there's no schools built on them. So these could also be built. We can add new schools to be built on these white lands. So this is the demand, which is on the left. All these issues, and the supply are how we can resolve them by the facilities existing. So this would go into our algorithm, and then we would get the output. The output would come in 4 formats: recommendation table, recommendation map, recommendation reports, and recommendation statistics, which is the dashboard we're all used to see. I'll be more specific, and I will dig into the TBC demo right now, just to understand how all of this works. So this is our interface here. This is all the educational facilities in the Kingdom of Saudi Arabia. And we are doing the planning, for the year. So if you look here, we have all the different types of schools I explained. The student growth, which is what will come in the future. The afternoon schools, rented schools, overcapacity, dilapidated schools, and underutilized schools. So I start by selecting my demand. So I want to resolve the issue of rented schools and overcapacity schools. And then I sort them, which one I want to have on top. And I have, for rented schools, I can solve it with the current supply, or future supply, but overcapacity only with current supply. I gave higher priority to rented schools, and And now I'm setting the supply, what I can use it. So for rented schools, I can solve the current supply by the undercapacity schools, because I can move students from rented school to a school I own currently, which has undercapacity. And I can also use it for the ongoing projects to distribute students on them. So I'm using which supply I'm going to use for my demand issues. So my demand here is to reduce the rented schools. So the demand is to allocate the students in the rented school to the available supply, which is the available seats in the undercapacity schools and ongoing projects. I'm doing the same also for the overcapacity. I'm going to use the undercapacity schools. Now I'm going to specify the business rules. So the distribution parameters, I can use buffer distance or driving or walking distance. I assign what is the maximum distance each student is going to walk for each type of school, kindergarten, elementary, intermediate, secondary. I can make also people only to be assigned to the same territory. Also, I assign the maximum supply capacity. I don't want my schools to be more than 90% occupied. And the minimum number of students to open a new school. Let's say I'm giving a recommendation that I should start a new school in this area. So I give what is the minimum number that I have to allow the ministry to make it make sense to build a new school. So these are all criteria that you can use for planning. Next, I'm going on my capacity parameters. So I'm saying what is the maximum classroom capacity for each stage. And if I have an empty building, we have some regulation that, let's say if I have a plot of land which is 100 meters, so I give 1 student per meter square, per 15 meter square. So I set all of these criteria for the empty buildings and for the empty lands or empty slots that I'm going to build new building in them. So I apply all of my changes to my model. Then I pick up the filtering criteria. As I mentioned, I select to which extent I'm going to apply these. So I'm going to run this on which type of boundaries. So in this case, we had the administrative boundaries and we had the ministry boundaries, like the educational boundaries, because they were different. So we asked the educational, am I going to run it on all departments or in a specific city or a specific area? So here they picked Riyadh, which is the capital. And inside the city, which neighborhood or which distribution. And then we run the algorithm. So after the algorithm is running, so it's gonna have, these are the criteria we're doing on the boundaries of the educational boundaries on the department level, on that minimum level, which is Riyadh. And which is the target here? What are the genders? Because they have different schools for different genders over there. And these are the 2 demands we were working on, the rented schools and the overcapacity schools. So we get a consolidated report giving you what is the resolution you should take. We can display the result of the report. So for rented schools, we are looking at, there are some part which was solved, some potentially solved, some non-solved. And the required supply, because this is a school that we need to resolve, we need 19 seats to resolve it. And these are the potentially solved, these schools, and what is the supply we need, how many seats we need. And these are the non-solved ones. If you look at the statistics, so using that, we were able to close only 1 school. And we are going to use 15 of the ongoing projects for 15 schools, and the rest we're going to keep them operating. And we see how much rent we've saved when we do that. Potentially saved rent if we do the potential recommendation, and the non-saved rent that we did not resolve. And then you can see which resources we used to resolve this question. So we used under capacity schools and ongoing projects. These are the ones we picked earlier. So this is the dashboard that shows you the recommendation of what you're going to do if you apply these rules, what you're going to save for the ministry. So now we're looking at the details of each supply to demand assignment. So I said we need 19 seats. So it's showing you that these 19 seats, what are the people? They are in which educational grade? And each of the schools that will take these 19 students, 11 will go to this school and 8 will go to this school. And you see the rent value, and the potential saving that you will do in that rent value. But in that case, data was not proper, so it's showing 0. But once you do this movement or reallocation of students, you're going to save the rent. So this is the supply to demand assignment, what I just explained. Now you can see the demand type. You can see the school on the map. There are 3 schools that are going to take the allocation from it. Just to understand how you're going to reshuffle your students. That's the other case. Oops. So that's it from my end. But just try to think about how we can use this master planning tool or optimization tool for any other use case. It can be used for hospitals, for ambulances, for warehouses, for food distribution centers, Ministry of Supply, food security. There's a lot of ways that this could be applied. And it's all based on AI and on GIS, of course. I hope you enjoyed my presentation today. Please feel free to reach out to us and feel free to attend. We have more sessions going on in all breakout rooms. And you can see my name and my contacts in case anybody wants to reach out. Thank you very much. And to you, Ronald.